Hi, this is Alyssa Hundley, and this is my final presentation for CIT 260. I just wanted to start off saying that this has been one of the most difficult classes that I've ever taken, but also one of the most rewarding. I feel like my understanding of programming, specifically object-oriented programming, has grown substantially in the last few months, and I've enjoyed watching the concepts come together and being able to finally grasp and understand the bigger picture. The group work that we did was extremely beneficial, and I'm so grateful for my teammates and all of their hard work. To start off, I'll explain the difference between a static class variable and a non-static or instance variable. Static variables are declared outside a method or constructor. They don't belong to any instance, but rather belong to the class itself. Only one of these variables can exist. In my code, you can see a static variable player of type player. We made this variable static because this player will only exist once. When a new game is started and the user creates a player, they are the current player of the game. There can't be another player besides this one that is created. For an instance variable, however, they are not declared static. In the example shown, I have instance variables of name, cost, weight, and quantity in my item class. There can be many item objects, and each item will have an instance variable, these instance variables specifically, assigned to it of different values, however. Instance variables are associated with objects. Now I will give examples and explain the differences and benefits of arrays and array lists. In the past, I have preferred using array list. I always thought that I'd like to have the option to add or delete items from an array, so I would just make everything an array list. Now, however, I can better distinguish when it's beneficial to use one over the other. Here's an example of an array list in our Mormon Trail project. You can see that it's commented out. This was code I created for an individual assignment towards the beginning of the semester. As we developed more of the program, we realized that this wasn't the best way to keep track of our characters, but here it is as an example. The basic functionality was to create an array list of characters that had not originally been assigned to the party. This list of available characters would display in the hotel scene view, and the player could pick a new character to add to the party. I made this an array list because we didn't know how many available characters there would be. It depended on how many died and how many characters the player wanted to include in the party at one time. And array lists worked well in this example because we could add or remove character objects whenever we needed to. We ended up using arrays everywhere else in our program. Arrays are given a defined length, and this worked well for the list of players or characters, items, and locations. Here we created an array person of type persons. This array was defined to be 10 in length, and using the create persons method, we added 10 person objects to the array. There will only ever be 10 persons in the game throughout the course of the game. You cannot add nor delete persons, which is why an array works perfectly for storing their information. We created an enum called person type. This enum gave a specific location to the names of the person, and then using an enum ordinal, we set that person type to the same location within the array, which you can see here underneath each person. I have previously taken a Java class, but was only ever introduced to for loops. This semester, I had the opportunity to learn more about for each loops and to use them in our program. First, this is an example of a traditional for loop. I used a new variable iCount and set it equal to 0. Each time the program loops back around, iCount increments by 1, as long as iCount is less than the length of the items in the array. Once it gets back to the top of the loop and iCount is equal to the length of items, the program exits out of the loop. This loop was used to find the location in the array of the item that the user selected to buy. It would then pull out the cost of that item and add it to the total amount of money that needed to be subtracted from the player. For each loops work a little differently. This is an example of one I made when printing out and saving the list of items. An error that we often made, and maybe it's not really an error, but we would name our array to be the same as the name of the object. And so sometimes it can get confusing about which one we were referring to. This is one of those instances, so I apologize in advance. Here I declare a variable items of type item. Then there's a colon and then the name of the array. This for each loop will go through the array item, then using the newly declared items variable, we'll get the name and quantity of each item. Each name and quantity is printed out every time the loop is executed. In this next example, I will show where a custom exception is being thrown, where it's caught, and how the error is handled. Going back to my example of printing a list of items, the user is prompted to type the file path they would like the report saved under. The program will first check for a game control exception and executes the code in its block if this runtime exception occurs while executing the try block. This exception occurs if the name of the file path that they enter is less than 2 characters. The exception is caught in the print item view class. It will display a message that says error occurred and then give the name of the file path that the user entered. This is a graceful way of handling the error. Handling exceptions is taking me a little while to understand, but I now can see that they are necessary to keep a program from crashing. First, it organizes the code so that all exceptions are connected. In my example, there were only 2 steps to propagating the exception up the call stack, but in more complex programs, it may be many steps to get back to where the exception is originally caught. I think that this keeps code from being repetitive. These custom errors are all caught in one place, and every exception that is thrown links back to that. This tells us where an error is happening. Java used to only support byte streams. Byte streams read and write binary data. They only do it 1 byte at a time in a sequential order. It only supports English, French, German, and Spanish, or Western languages. Character file streams, on the other hand, support all languages. Java uses Unicode to store character data. Anytime you're printing to the console a text file or paper, it is best to use a character output stream. They allow you to read and write output data regardless of the format of the data. There are various character stream classes that allow you to read and write data in different formats. This last example is to show how to write data to an external file. Once again, we'll be looking at something I did for an individual assignment, the print items report. In the print item view, the user is asked to enter the file path to which the report should be saved. The method to execute this request is in the game control class. The content for the file or the items are also created in the game control class. In our main class, Mormon Trail project, we declared private static class instance variables for the output files using the printWriter class. We then created a new printWriter object and assigned it to the out file attribute. This opens character stream files for the end user output. When the user says which file path they would like to report to, we have the ability to do that. Going back to the print items report method, the method first creates a printWriter stream and a try with resource statement for the file at the specified file path. Then, as mentioned earlier, the for each loop executes, printing the items in the desired format. Finally, I can show you our program. So I'm going to run it here in NetBeans. First, I will start the program and it prompts me to enter my name. We have several menu items right here. A few of them we included so that we could test parts of our game that aren't yet connected to the rest of the program. By pressing G, I can test the general store view. I will press B to buy some supplies, and then L saying that I want to buy a large wagon. It will then prompt me and ask me how many I want to buy. So I'll press 4. And then it says I just added 4 large wagons, and then takes me back asking if I want to buy any more items. So I'll press Q to go to a previous menu and to get out of the general store view. So I'll go back to the main menu and then press P to see the team pace. And then it'll still ask me what team pace I want for that day. So I'll press A for average, and then it will display that our team pace is 1.5 for today. So I'll go back again to the previous menu, to the main menu. And these little test menu items have been really helpful for us to check and make sure that we programmed everything correctly and that everything is working as it should be. I'll press N to start a new game, and then I'll click M, and it displays our map that we have there. And then I'll go back to the main menu, and I'm going to press S to save the current game. So then it prompts me and asks me which file path I want to do. So I'll save it to test save, and then press enter. And it says game was successfully saved at test save. And then if I go and open up my Finder, I will see that there is my test save file. Thank you for watching. I hope you enjoyed seeing how our program works.